Today you are going to do the Topic 7 review. Please follow along and listen carefully and think about everything you're doing. Number 1. Courtney has 36 photos to arrange on a gallery wall. We want to find out how many arrays can Courtney make with 36 photos. And we need to list all the possible arrays. So basically we need to find the factors of 36, which happens to be the second question as well. So we can kind of do both of them at the same time. So we want to find the factors of 36. Let's use our divisibility rules to help us, and let's use our rainbow method. So we're going to start with 1 and 36. Well, we know that 36 is even, so 2 is going to be a factor. So 2, and if you divide 36 by 2, you would get 18. 2 and 18. I know that 3 plus 6 is 9, and since 9 is a multiple of 3, I know 3 is going to be a factor. So 3 and 12 are also factors of 36. I know that 4 goes into 36, and 4 times 9 is 36. 5 won't work because it does not end in a 0 or 5, but I know that 6 times 6 is 36. Now I know that I have all the factors because I've reached the middle. So the different possible arrays are 1 row of 36, and 36 rows of 1, because you have to be able to write them both ways. Also, we could do 2 rows of 18 and 18 rows of 2. I can also do 3 rows of 12 and 12 rows of 3. So 12 rows of 3, 3 rows of 12, and we've got 4 rows of 9 and 9 rows of 4, and my last way is 6 rows of 6. I'm going to type these a little bit neater for you, so just hold on a second. On your paper, you should have everything that I've just written down, and make sure you use your divisibility rules to get all the factors, because if you're missing even one factor, then the whole question is wrong. So you should have 1 row of 36 and 36 rows of 1, 2 rows of 18, 18 rows of 2, 3 rows of 12, 12 rows of 3, 4 rows of 9, 9 rows of 4, and we have 6 times 6. So when it asks how many factors are there for 36, we can count them. We have 1, 2, 3, 4, 5, 6, 7, 8, 9. We have 9 factors for 36. Now it's telling us to write them. Well, since we already wrote them, we could take an arrow and just point up to where we wrote them. What do you notice about the factors for 36 and the numbers of arrays? Well, there are 9 factors, right? Which we've already written down. And if we count the arrays, which we've already highlighted, there's 1, 2, 3, 4, 5, 6, 7, 8, 9. There's 9 arrays. These are the arrays. So the number of factors is the same amount as the number of arrays. Make sure that you write this sentence down in your math notebook, because you will have to write it on the test. Now it's asking Write all the factor pairs for 36. Is 36 prime or composite? Well, we've already wrote all the factor pairs because that's the number of arrays. And this number is going to be composite because it has more than 2 factors. Number 2. Peter wrote 4 sets of numbers. Which set shows only multiples of 6? Alright, so multiples of 6. We have 6, 12, 18, and 24. If we multiply 6, all these numbers would be multiple of 6 because 6 times 1 is 6, 6 times 2 is 12, 6 times 3 is 18, and 6 times 4 is 24. So this one would be yes. Now let's look at the next option. We have 6, 16, 26, and 36. Well, this would not work because 6 times nothing would be 16, and 6 times nothing would be 26. But 6 times 1 is 6, and 6 times 6 is 36. So it has 2 factors, or 2 multiples of 6, not all 4. So this answer would be no. 1, 2, 3, and 6, that would also be no because those are the factors of 6, not the multiples. And last, we have 6, 60, 66, and 600. Yes, those would all be multiples of 6 because 6 times 1 is 6, 6 times 10 is 60, 6 times 11 is 66, and 6 times 100 is 600. Which statement is true? The only factors of 3 are 3 and 1. The only factors of 4 are 4 and 1. The only factors of 6 are 6 and 1. And the only factors of 8 are 8 and 1. Well, the only one that would be true would be A, because since 3 is a prime number, the only factors of 3 are 1 and 3. All of the other numbers are even and will have 2 as a factor. Number 4. Choose the correct word from the box to complete each statement. Well, I know that 19 is a prime number because it only has 2 factors. I know that 12 is a composite number because it's even. I know that 33 is also a composite number because 3 plus 3 is 6, so it will be a multiple of 3. And I know that 3 times 11 is 33, so it's going to have more than 2 factors. And 17 would be prime because it only has 2 factors. You can go ahead and skip number 5. If you want to try it though, it is a fun one to do. It's like a puzzle, and you can show me when you're done after you finish the rest of this review. Go back and you can do number 5. Number 6, we want to write 3 multiples and 3 factors for 24. So on your test, you will write an M for multiples and draw a line and put an F for factors. I'm going to do this on the side right here so we have more room. So let's start with the multiples of 24. Well, any number times 24, the product or the answer would be a multiple. And we know for multiples, they are going to be larger than 24 or 24. So I'm going to use 24. I'm going to use 240. And I know 24 plus 24 is 48. There are 3 multiples of 24. Now I'm going to write the factors for 24. And we only need to write 3 of them, even though there's more. So those are the numbers that we're going to multiply to make 24. I know 1 times 24 is 24. So there's 2 right there. I also know that 2 times 12 is 24. So I actually wrote 4 factors, even though I only needed to write 3. Number 7. Corky wrote, oops, sorry about that. Let me erase that. Here we go. Corky wrote a list of factors and a list of multiples. Draw lines to match the factors with the multiples. Well, I know that 7 times 7 is 49. Make sure you draw a straight line. I'll draw it darker so you could see it. I know that 9 times 3 is 27. I know that 5 times 5 is 25, and I know 2 times 3 is 6. All right, number 8, and this one is on your test. They all are, but this one is one that a lot of kids get wrong on the test, because if you don't answer them all correctly, the whole answer is wrong. So we need to select all the statements that are true. So let's read them. First of all, we have a composite number has at least 3 factors. Yes, that is definitely true. A composite number has more than 2 factors. All right, let's read the next one. It says, all prime numbers are odd. Well, that is not true, because I know a lot of prime numbers that are not odd or that have more than 2 factors. The third one, 99 is a prime number. Well, I know that's not true, because 9 plus 9 is 18, and 18 is a multiple of 3, so 3 would be a factor. The next one, 2 is the smallest prime number. That is definitely true. 2 is the smallest prime number and the only even prime number. All right, next problem. All even numbers greater than 2 are composite. That would be correct. And the last one, all prime numbers, sorry, I keep messing up with my highlighter. Let's try that again. All prime numbers have 2 factors. That is true. All prime numbers have exactly 2 factors. When you're doing this part on the test, make sure you're reading it and thinking about each problem carefully, and use your common sense to figure out if the statement is true. The ones on the test will be a little bit different than the ones I'm doing right now. This one is also going to be on your test almost exactly like this. It says, Marika says factors and multiples are related. Use the equation 6 times 7 equals 42 to describe the relationship between factors and multiples. In order to get this question correct, you need to have a sentence with something like this. 6 and 7, over here, they are factors of 42. You would also have to say that 42 is a multiple of 6 and 7. So whatever number it is using, you want to make sure that you clearly explain the relationship, that the numbers that you are multiplying are factors, and the product or the answer is the multiple of those 2 numbers. If you write this exact sentence, you would get full credit. Which lists all the factors of 25? So this is just not asking for just some of the factors. We want to know all of the factors. So if we use our rainbow method and we have 1 and 25, well, I know that 25 is not even, so 2 will not be a factor. 3 will not be a factor because 2 plus 5 is 7, and 3 is not a multiple of 7. 4 is not a factor, but I know that 5 times 5 is 25, so I have 5 as a factor. There are no other factors of 25. So my answer is B. 1, 5, and 25. Number 11. Carter lives on a street where all the house numbers are multiples of 6. We need to name 2 possible house numbers between 601 and 650. So if we know that they're a multiple of 6, and so I know that 606 would work. I'm going to put that in here because that would be a multiple of 6. I know for my rule for a multiple of 6, it has to follow the rules for 2 and 3. So it has to be even, and when I add the digits, it has to be a multiple of 3. Well, 606 is even, and when I add them up, it's 12, and I know 3 times something is 12. Well, if I add 6 more to 606, I get 612. I know that will also be a multiple of 6. And if I add 6 more, I get 618. There are 3 multiples of 6 that are between the numbers of 601 and 650. There are other ones too, but it is just asking for 3. Number 12. We need to write, whoops, sorry about that. Let me erase that. We need to write each number in the correct answer space to show factors of 27 and 35. Let's start with 3. I know that 3 times 9 is 27. So I'm going to underline my 3 and my 9 and put them in here. 3 times 9 is 27. I know that 5 times 7 is 35. So I'm going to put 5 and 7 in this box. 27 would be a factor of 27. And 35 would be a factor of 35. Last problem. It says, Xavier says, whoops, I'm going to fix that again. Keep forgetting to switch it to the highlighter. Xavier says all odd numbers greater than 2 and less than 20 are prime. Find an odd number greater than 2 and less than 20 that is not prime, and explain why the number is not prime. Well, an odd number that is greater than 2 and less than 20 could be 9. And I know it's not prime because 9 has the factors of 1, 3, and 9. So it has more than 2 factors. Let's take a look at the performance assessment. Arranging cars to sell. Miss Oritz owns a car dealership. The dealership has inventory of cars listed in the Oritz car dealership table, which is over here on our right. Miss Oris wants to arrange all of the trucks in the front lot. She would like to have the same number of trucks in each row, therefore making a rectangular array. Part A. In how many different ways can the trucks be arranged in the front lot if the same number of trucks are parked in each row? Well, if we look at the trucks, there are 15. So we have to find the factors of 15. So I know they could be arranged 1 row of 15, 15 rows of 1, 3 rows of 5, and 5 rows of 3. Part B. What are all the ways the trucks can be arranged? Draw and label the different arrays. I kind of already did this one right here, but we never wrote in Part A how many ways. So the answer for how many ways would be 4 ways. And then we already did the ways up here, so I drew an arrow. Part C. Miss Oritz would like the arrangement to have more than 2 rows of trucks, but less than 6 rows. What are the ways the trucks can be arranged? Explain. So if she wants more than 2 rows, we could not use 1 row of 15. She also wants less than 6 rows. So we could not use 15 rows of 1. The only way that would work would be 3 rows of 5 or 5 rows of 3. Since she wants more than 2 rows but less than 6, these are the only ways that it would work. In the first one, she would have 3 rows of 5 trucks, which would be more than 2, and less than 6. And in the second one, we would have 5 rows of 3 trucks, which would also be more than 2, but less than 6. These are the only 2 ways that would work. Please come show me when you are done with the review.